Today, we're gonna talk about how the American West was born from fire and forged by Yellowstone. If that sounds like a cheesy title for a nature documentary, well, it is, because it is one. And now that it's been released, I can finally tell you all about it. It's the story of how Yellowstone shaped the landscape, how life evolved around it, and what might happen if it erupts again. So here's the deal. Hi, I'm here to bring you news from the world of Roman archaeology, and other stuff too. Now, I've never made a video specifically about North America before. Most of my content focuses on Europe and the Mediterranean. But last summer, I got the opportunity to go out west and visit some of the amazing sites there. And this video is the result of that trip, plus more research than I can shake a stick at. It's also a good excuse to play with some new filming equipment. So let me show you a little bit of what we have in store. Okay, so here's the deal. Yellowstone has been there since the Eocene epoch, which began 56 million years ago. When the supervolcano first formed, it was in an entirely different place. The North American plate was moving southwest and carried the hotspot that would become Yellowstone with it. So instead of being in the middle of the continent, the Yellowstone hotspot was over here. It wasn't until about 17 million years later that the Pacific Northwest was hit by a series of earthquakes that shifted the entire region up and over. By then, the Yellowstone hotspot was where it is today. The first eruption of Yellowstone itself is thought to have occurred around 2.1 million years ago, but the area had already been volcanically active for millions of years before that. There were huge outpourings of flood basalts, vast layers of lava that spread out for hundreds of miles, covering much of what is today Idaho, Montana, and Wyoming. We think these flood basalts were connected to Yellowstone, but they predate the formation of the caldera itself. Here's why scientists think this. See, one of the main tools we use to understand how old something is radiocarbon dating. This method looks at the decay of carbon isotopes in organic material and allows us to date things up to about 50,000 years old with reasonable accuracy. But dating things further back than that gets trickier. That's where potassium-argon dating comes in. It uses the ratio of potassium to argon in a sample to date the rocks it's found in. But it only works on certain kinds of rocks. And while potassium-argon dating has allowed us to date parts of the flood basalts to be between 13.6 and 9.6 million years old, it doesn't work on rhyolite. Rhyolite is a very viscous kind of rock that makes up most of Yellowstone's visible volcanic structures. And because it doesn't contain enough potassium, we can't use this method to date it. All we know is that it's younger than the flood basalts. In order to figure out just how much younger, researchers collected samples of soil from the bottom of Yellowstone Lake. They dated the pollen and charcoal found in the soil using radiocarbon dating, and their results showed that the lake formed sometime after 14,000 years ago. Then, using potassium-argon dating on the rhyolite, they learned that the first major eruption of Yellowstone occurred between 2.1 and 1.3 million years ago. Now, it's important to remember that when dealing with timescales longer than a few thousand years, we don't talk about years BC and AD. Instead, we use terms like 1,000 years ago, or in this case, million years ago. So when people say that the first eruption of Yellowstone was 2.1 million years ago, what they mean is that it happened 2.5 million years before today. It's also important to remember that on a geological timescale, a million years isn't a very long time. People have been around for 300,000 years. The first hominins appeared 6 million years ago. Life on Earth has been around for about 3.8 billion years. A million is a blink of an eye compared to that. So, yeah, that's when Yellowstone first blew its lid. But things really started heating up around 640,000 years ago. That's when the Lava Creek eruption occurred. It unleashed 2,400 cubic kilometers of ash and pumice and left behind the vast majority of the rhyolite we see today. And while all of this was going on, life was trying its best to adapt. The Yellowstone eruption created such a hostile environment that any plant or animal unlucky enough to be in the direct path of the blast went extinct. But elsewhere, life found a way to carry on. One example is a beetle called Paranthomyidae. This is a type of scarab beetle that lives in dung. and fossils of this particular species have been found throughout much of the Rocky Mountain region. They first appeared in the fossil record about 30 million years ago, and during the Pleistocene epoch, there were a variety of different species living in the area. But when the lava creek eruption blasted them with ash, it wiped out every single one of them, except for one species, Paranthomyidae trigonus. After the eruption, this one species migrated southwards into Mexico. Once the landscape began to recover, they radiated outwards once more, repopulating the Rockies with their many descendants. Another example is the pocket gopher. Their ancestors lived across the Great Plains until the Yellowstone eruption blasted a massive amount of ash into the sky. See, pocket gophers are adapted to living in flat, open spaces. Their burrows are simple and straightforward, and don't require a lot of digging. But after the eruption, much of the landscape was covered in thick ash, which made it difficult for them to burrow. And because of this, they went extinct everywhere except for one small region in southwestern Wyoming. Here, the terrain was full of hills and ridges, forcing the pocket gophers to dig more complex burrows with multiple entrances. But while this made them more vulnerable to predators, it allowed them to survive the upheaval and repopulate the Great Plains afterwards. But humans were never far behind. About 12,000 years ago, people arrived in the Yellowstone region. These were the ancestors of the modern Native Americans, and they came across a land reshaped by both geology and glaciers. Much of the Rocky Mountain region was covered in ice as recently as 15,000 years ago, and it wasn't until 12,800 years ago that the Yellowstone region was completely free of ice. What the landscape looked like at that point is pretty similar to what we see today, but the forests were denser and the mountains were a bit taller. You see, the weight of the ice sheets actually depressed the land beneath them, so they were much lower than they are now. The melting of those glaciers caused the land to rebound, a process that is still happening today. The northern part of the region is rising at a rate of about 1 centimeter per year. The people who lived in the region 12,000 years ago belonged to the Paleo-Indian culture. They were nomadic hunter-gatherers who followed the herds of bison and other animals they depended on for food. Their technology consisted of spears, knives, and projectile points, usually made of bone or stone. They weren't farmers, but they did occasionally engage in what we call domestication, selectively breeding plants and animals for desirable traits. For example, the sunflower is believed to have originated somewhere in the Great Plains. Originally, wild sunflowers grew to a height of only about 1.5 meters, but over time, people began selecting the largest and most abundant plants to grow, gradually increasing the size of the flower heads. Corn is another example. Archaeological evidence suggests that the earliest form of corn, teosinte, was domesticated in southern Mexico about 9,000 years ago. Eventually, people brought this new domesticated crop northwards, where it became an important part of their diet. This was the situation when, about 2,000 years ago, the first historical cultures began to appear. The best known of these are the ancestral Puebloans, also known as the Anasazi, who built great houses out of stone and clay. They farmed and herded animals and thrived in the region for centuries. Unfortunately, around 1300 AD, they abandoned their settlements and migrated southwards, possibly due to a combination of drought and overpopulation. The next culture to occupy the region were the Shoshone, who arrived sometime around the 1700s. At this point, the landscape looked pretty much exactly the same as it does today. The forests had reached their current density, and the land had mostly recovered from the effects of the last ice age. In fact, the only real difference was the presence of large herds of bison. These animals had gone extinct in the east long before this, but the Yellowstone region was one of the last places they inhabited. Then in the early 1800s, Lewis and Clark arrived, followed closely by the first wave of settlers. Today, the region is home to 7 US states, over 50 million people, and a whole host of national parks. Millions of visitors come to see the geysers and hot springs of Yellowstone National Park each year. And just next door is the aptly named Grand Teton National Park, home to North America's tallest mountain. We can't talk about the American West without mentioning Mount Rushmore, a granite mountain carved by wind and rain over millions of years. That is, until a sculptor named Gutzon Borglum decided he wanted to carve 4 presidential faces into it. And then there's Arches National Park, with its nearly 2,000 natural sandstone arches, or Canyonlands National Park with its vast expanse of canyons, mesas, and buttes. But despite all this human activity, Yellowstone remains a wild and untamed force of nature. Sure, we've learned to live around it for the most part, but we can't control it. And while it's unlikely to happen in our lifetimes, the possibility of another major eruption looms over everything. If it does blow its lid again, the damage will be catastrophic. The ash will cover much of the Midwest and eastern US and throw the world into darkness. Crops will fail, infrastructure will collapse, and countless lives will be lost. The economy will grind to a halt, and we'll spend years recovering. But maybe that's not a bad thing. Maybe it's time we learn to live smaller, simpler lives, closer to the land. Maybe it'll force us to reconnect with the natural world and rediscover traditional skills like farming, animal husbandry, and crafting. Maybe we'll even start seeing the stars again polluted by artificial light. Who knows? Maybe Yellowstone will forge a better future for us after it destroys the old one. If you want to find out more about what life would be like after a Yellowstone super eruption, check out this playlist here. And thank you to my supporters for helping to make all of this possible.